Hi, my name is Alyssa, and I'm your math and science tutor. Today, we're talking about degrees and radians. In our previous video, we talked all about the four quadrants, like you see here, and we talked about them using degrees. We did so because most people are comfortable with degrees because we see them in our everyday life. When working with degrees, you'll always see them denoted by the degree symbol. So you can tell if you're working with degrees or radians based on if you see the symbol or not. Now let's talk about radians, because chances are, if you're watching this video, you haven't worked with them much or maybe you've never heard of them at all. To understand radians, we need to understand some terminology. In this diagram, I have drawn the circumference of the circle in red. The circumference is just the perimeter or outside of a circle. The radius is in blue. And the radius is just the measurement from the center of the circle to the outside of the circle. Next, we have the diameter. The diameter is shown in green. And the diameter is the total length across the center of the circle. It is twice the length of the radius. Finally, the arc length is in purple. And it's just the distance between 2 points along the section of a curve. So now that we know these things, we can define or understand what a radian is. When the radius of a circle is equal to the arc length, that equals 1 radian. And we can put those words into an equation. The arc length divided by the radius will equal radians. So say, for example, we had a radius of 3 centimeters and an arc length of 3 centimeters. How many radians would that be? We take the arc length divided by the radius, and 3 divided by 3 is 1. So we have 1 radian. Now let's say we have a radius of 4 and an arc length of 8. How many radians would that be? We take the arc length of 8 divided by the radius of 4 to get 2 radians. And finally, let's say we have a radius of 2 and an arc length of 16. What does theta equal? We have 16 as our arc length and a radius of 2, so we have 8 radians. So now that you know what radians are, it's important to be able to convert between them and degrees. You may be faced with a problem where you're asked to convert to one or the other, or you may be able to better understand a problem by converting. So let's do that now. First, you need to know that one rotation around a circle, or our 4 quadrants, is equal to 360 degrees. One rotation is also equal to 2 pi radians. So 360 is equal to 2 pi radians. When we set 360 equal to 2 pi, we can divide both sides by 2 to get 180 degrees is equal to pi. We can use that to convert between the two, between radians and degrees. So let's convert pi over 4 radians to degrees. We'll start by rewriting pi over 4. Then we need to multiply pi over 4 by 180 degrees over pi. Why do we put degrees on top and pi on the bottom? Would it work if we instead used pi over 180? What do you think? This is important. When converting from radians to degrees, we have to multiply our radians by 180 degrees over pi, because we want the pi in the numerator and the pi in the denominator to cancel. Remember that anything divided by itself is 1, so we can get rid of pi completely. And then we're just left with degrees. If you're allowed to use a calculator, you can plug that in to get your answer. But you might have to show how to do this without a calculator. So let me show you a simple way to do this without one. We have 4 in our denominator, so we want 4 in our numerator. We can break 180 into 4 times 45, and then we can cancel the 4's. So now we're just left with 45 degrees. And 45 degrees is our final answer. Now, how about pi over 2 to degrees? We're going from radians to degrees, and we want pi to cancel, so we need to multiply by 180 degrees over pi. Let's do that. The pi can cancel now. Now we have 2 in the denominator, so we want a 2 in the numerator so that we can cancel the 2 2's. We can break 180 into 2 times 90 degrees, and we can cancel those 2's, and we're just left with 90 degrees. And 90 degrees is our final answer. Go ahead and pause the video and try this one on your own. All right, hopefully you tried that. We're going from radians to degrees, so we need to multiply by 180 over pi. Right away, we can cancel the pi, and we're left with 3 times 180 over 2. We have a 2 in the denominator, so we want a 2 in the numerator. We can rewrite 180 as 2 times 90. We can cancel the 2, and now we're left with 3 times 90. 3 times 90 is 270 degrees, and that's our final answer. Now let's take a look at this problem. We're asked to find theta and write it in degrees. We can use the equation that we learned earlier to do that, but it's important to note that that equation will give our answer in radians, and it only works with radians. So we're going to need to convert our answer to degrees. We'll start by taking our arc length divided by the radius to get 4 radians. But we need to write this answer as degrees, so we need to convert. We're going from radians to degrees, so we need to multiply by 180 degrees over pi. We'll punch this into our calculator to get 229.2 degrees as our final answer. Now that you know how to convert from radians to degrees, let's convert from degrees to radians. We have 60 degrees to convert to radians. We'll rewrite our 60 degrees, and now we need to multiply by pi over 180 degrees. That's because we have degrees in the numerator and we have degrees in the denominator, and we want them to cancel. Right away, we can start canceling those degrees because we set up our problem correctly. We have 60 degrees in the numerator, so we want to have 60 degrees in the denominator. It turns out we can break 180 into 60 times 3, and we can cancel these 60s. We're left with pi over 3. And that's our final answer. Now let's convert 135 degrees to radians. We'll rewrite our 135 degrees, and we'll multiply by pi over 180 degrees. Remember, we always want our degrees in the numerator and in the denominator so that we can cancel. We've set up our problem correctly, so we can start canceling. 135 can't go into 180 equally, so it's a little trickier to know what to break our numbers apart into. But if you know your divisibility rules, it shouldn't be a problem for you. From our divisibility rules, we know that 135 and 180 are both divisible by 5. So let's break them down so that the 5's can cancel. 135 can be broken down into 5 and 27, and 180 can be broken down into 5 times 36. We can cancel these 5's. We can go further because both 27 and 36 are divisible by 9. We can break 27 down into 9 and 3, and 36 into 9 times 4, and we can cancel these 9's. So now we're left with 3 pi over 4. And that's our final answer. Now pause the video and try to convert 220 degrees to radians, and we'll go over it together once you're done. All right, our first step is to rewrite 220 degrees and multiply by pi over 180 degrees. We have degrees in the numerator and in the denominator, so we can cancel them. We can break 220 and 180 down because they're both divisible by 4. Just as a side note, these numbers are divisible by other numbers as well, so if you broke them down a different way, that's okay, as long as you end up with the correct answer. We can break 220 into 4 times 55, and 180 into 4 and 45. We can cancel the 4s. Now we can break 45 and 55 down by 5. We can break 55 down by 5 and 11, and 45 down by 9 times 5, and we can cancel the 5s. We're left with 11 pi over 9, and that's our final answer. Before we move on, please like this video and subscribe to my channel. It really helps me to continue making helpful videos like these. Thanks so much. All right, now that you know how to convert, let's try graphing radians. You can do this 2 different ways. The first way is to label your axes with their radian values and graph in radians, or you can convert radians to degrees and graph in degrees. We're going to do it both ways, and you can choose what works well for you. So let's do the first problem by converting. We've got pi over 6, so let's rewrite that. And multiply by 180 degrees over pi. Remember, we're going from radians to degrees, so we want the pi to cancel. And since we've set this up correctly, we can cancel them. Now we have 6 in the denominator, so we want a 6 in the numerator. We can split 180 into 6 times 30. And we can cancel the 6s. We're left with 30 degrees. The terminal side of 30 degrees is right about here. All right, now let's try to graph 3 pi over 4 by labeling our axes with their values and radians. As you learn more in trig, you'll get familiar with these values and you'll be able to intuitively graph these values. As a matter of fact, I'll be talking about common values to know in this video, but we'll start with the axes right now. The positive x-axis is 0 radians. The positive y-axis is pi over 2. The negative x-axis is pi, and the negative y-axis is 3 pi over 2. 3 pi over 4 is greater than pi over 2 and less than pi, so we know it's in quadrant 2. And it turns out that it's directly between those 2 axes, so the terminal side goes here. At this point, that probably didn't make much intuitive sense to you, but it will as time goes on. Now go ahead and try to graph 7 pi over 4 on your own using either the degree or radian method, and we'll go over it together once you're done. All right, I'm guessing that more of you converted to degrees and then graphed, so that's what I'm going to do. We'll rewrite 7 pi over 4 and multiply by 180 over pi, and we can cancel the pi. Now we have 7 times 180 over 4. We can split 180 into 4 times 45 and cancel the 4s. Now we're left with 7 times 45, and that's 315 degrees. The terminal side of 315 degrees is right about here. All right, so as promised, let's go over some common angles that you should know. The radian values are in blue and the degrees are in red. These angles are all on the unit circle, which will become very important in upcoming lessons. I know this probably seems overwhelming right now, but don't worry. I don't want you to memorize these right now because I'm going to be showing you how to very easily memorize the unit circle in another video that I've linked in the description. I just want you to pause the video, Take a look at these angles to get acquainted with seeing them for the first time if you haven't seen them before. And then we'll wrap up the video by talking about why radians are actually important. A common question students have about radians is, why do we even need to use them? Why don't we just use degrees for everything? And I think that's a very fair question. So I'm going to try my best to help you understand why radians are your friends. It turns out that an ancient civilization came up with degrees because they estimated that it took about 360 degrees for the Earth to orbit the Sun. So they split the orbit into 360 parts, and that's why a circle has 360 degrees. So degrees are simply invented by humans and aren't really based on the geometry of a circle, whereas radians are. We learned earlier that when the arc length and the radius are the same length, that's equal to 1 radian. So radians are a natural unit in that they are directly related to the geometry of a circle. And as you get more advanced in mathematics, you will most likely find that they are easier to work with. That being said, both degrees and radians are still very important and have many uses, so it's important to be able to work with them both. If you have questions about anything we covered in this video, please leave them in the comments below, and I'll try my best to get back to you. To guarantee that your questions get answered, I am currently offering private tutoring sessions. Please check the description for details. Thanks so much for watching.